Right, so you all have your log tables on the go, don't you? Yeah, because you need this page on the log table so you don't have to keep flicking through the book. Okay, so you need page 25 on the log tables because all the rules are here on the left hand side. Okay, and while the first few rules you'll remember them, I think the sign cause 10, I always forget which one is the negative one, etc. So you need page 25 open in your log tables beside you at all times when you're doing differentiation, yeah? Yeah, are we good? You all own log tables, yeah? Right, okay. Right, okay, so I will go with a few examples. Right, okay, you needn't write them down. I just want to see how you go. So if I said y equals cos 6x, and I ask you to differentiate. So off you go to your log tables and you figure out that when you differentiate cos, you get minus signs. You get minus sign of the exact same thing, and then you multiply it, then you differentiate the angles. So differentiate 6x and you get 6. So your answer is minus 6 sine 6x. Is that okay? Yeah. Is there a problem there for anyone? That you learned this, it's okay. Yeah? Okay, right, let's go with a harder one. Okay, so if we said my function was y equals sine of 2x plus cos of 4x. So differentiate this. So differentiate, so it's like you just go across the line when they're added or subtracted. You just differentiate each one individually. So differentiate sine and you get cos of the exact same thing. And then you differentiate the angle, so it's multiplied by 2. Differentiate cos, you get minus sine of the exact same thing. And then you differentiate the 4x and you get 4. Is that okay? That's fine, and then you could write it, you can leave it like that, but you can write it as 2 cos 2x minus 4 sine 4x. Okay, don't be tempted to multiply the angle by 2, because it's not the angle multiplied by 2, it's cos of the angle multiplied by 2. Is that right? Okay, are we good? Right, okay, next type of one. If I told you y was equal to cos cubed 2x plus 1. So there's 3 parts to this. Right, remember cos cubed 2x is the same as cos of 2x plus 1 all to be cubed. That's just the way they write it. Is that okay? Right. So there's 3 parts to this. You have to differentiate the bracket, bring the power down in front, reduce the power by 1. Inside the bracket stays exactly the same. Then you differentiate the cos, differentiate cos, and you'll get minus sine, sine, minus sine, right? And then you differentiate the angle. So there's 3 steps, right? So the first thing is bring the power down in front, inside the bracket stays exactly as it is, and reduce the power on the bracket by 1, so that's to the power of 3, now it's to the power of 2. Right? Is that okay? Chain rule. Right, now I have to differentiate inside the bracket. So when you differentiate cos of 2x plus 1, you get minus sine of 2x plus 1. And then you must differentiate the angle. So differentiate 2x plus 1 and you just get 2. So there's 3 parts to it. You all with me? You've done one of these? You're familiar with it? You're okay with it? You're not convincing? Right, okay. So you have to do this 3 steps. You have to do the bracket. Inside the bracket stays exactly the same. The power in the bracket gets reduced by 1. Then you do the cos. So when you differentiate cos, you get minus sine of the exact same angle. And then you differentiate the angle. Right, so there's 3 steps. Right, did you use a substitution with a u or anything? No. Is this how you did it? Yeah, you didn't use a U or whatever because they do that way in the book. I prefer it this way. Yeah? Right, okay, and then you can multiply the numbers. 3 by 2 is 6. I'm going to rewrite, instead of saying cos of 2x plus 1 all to be squared, I'm going to rewrite that as just putting the square back in there. And then beside it, you can put, there's a minus there, I'll stick that at the front, and it's sine of 2x plus 1, and that's your answer. Right, but don't worry about the simplifying bit, okay, because if you give this line, you get full marks. Is that right? Any questions? Will you do one for me? Right, okay, so you just write down the answer to this. Y equals 10 cubed of 4x plus 3. And when you differentiate 10, you get sec squared x. So when you differentiate 10, you get sec squared x. You needn't worry about what sec squared means, just go with it for the moment. Okay? Ready? So that's 10 cubed means 10 of 4x plus 3 all to the power of 3. That's what 10 cubed or 10 cubed 4x plus 3 means. Okay, so you do the bracket, so bring the power down in front. Inside the bracket stays exactly as it is, and the power on the bracket reduces by 1, so it goes down to 2, right? Then differentiate 10. When you differentiate 10x, you get sec squared x. So you get sec squared of the exact same thing, right? And then you differentiate the angle, so you must differentiate 4x plus 3, and you just get 4. Is that alright? So 4 by 3 is 12. I just put that squared with the 10 as opposed to on a bracket, because this is how you write it. That should be squared. 4x plus 3, and then it's sec squared 4x plus 3. Do you get it? Are we okay? Can I move on, or do you want some more? Someone has to answer, because if no one answers, I think you're all great and move on. You're all great, so move on. Right, okay. So you tell me you did inverse trigonometric functions yesterday? Right, okay. I'm not sure how you did them, right, okay, but I always put the whatever it is, when you're differentiating, so if you have the inverse sine of, I don't know, what did I put? I'll just do inverse sine of 3x. I'll do an easy one to start with. Differentiate that, okay? So the rule for inverse sine is 1 all over the square root of a squared minus x squared. So you write this as x over a, as in you write the angle as x over a, so make it a fraction, okay? So x is 3x, so everywhere I see an x I'm putting in a 3x, everywhere I see an a I'm putting in a 1. Is that okay? So fill in this, so you get 1 all over the square root of a squared, which is 1 squared, minus x squared, which is minus 3x, to b squared, and then now you must differentiate the angle like before. So you've differentiated the inverse sine bit, and you get that. Differentiate 3x and you get 3. So you have to multiply by 3. Is that okay? So that would be multiply 1 by 3 and you get 3 all over the square root of 1 minus 9x squared. Is that okay? So that's a pretty straightforward one, right? So remember, you in the book it's inverse sine, or in the log tables x over a. Okay, so you write it as a fraction. Are we good? Right, I'll take that as a yes. So now right, if I want to get the inverse 10 of x over 4. Right, girls, when it's already a fraction, right, the easiest thing to do is just put it over 1. Always put it over 1. So even if it's a fraction, put it over 1. I find that the easiest thing to do, right? I don't know how you learned how to do it yesterday with Miss McNamara, but this is the way I teach it. Okay, so, sorry. Right, so even if it's a fraction already, still put it over 1, right? So x is whatever's above the line, so everywhere I see an x, I'm putting in an x over 4, right? And everywhere I see an a, I'm putting in a 1. If you do it this way, girls, you'll always be putting in a 1 for an a, right? So even if it's a fraction already, put it over 1. So a will always be 1, and x is always whatever that is. Is that right? Then the formula for inverse 10 is a all over a squared plus x squared. Right? So everywhere I see an a, put in a 1. So it's 1 all over 1 squared plus x over 4 to be squared. Now, and then you multiply it. Now you must differentiate the angle. So differentiate x over 4. Differentiate x over 4. What do you get? You get the number for, you know, if it was 3x, you'd get 3, wouldn't you? If it was 4x, you'd get 4. So if it's x over 4, that's the same as writing a quarter x, isn't it? So when you differentiate it, what will I get? A quarter. So you must multiply it by a quarter. Is that okay? So that's 1 all over 1 plus x squared all over 4. And then multiplied by a quarter. Agreed? Right, okay, so multiplied top, 1 by 1 is 1. Multiplied by the bottom, 4 by 1 is 4. 4 by x squared over 4 is just x squared. Is that okay? That's your answer. Are we good? Did you do some of these for homework? Do you want me to correct them? Which ones did you do for homework? Can I do them all out?
We did question 1, 2 and 5 on exercise 7.8.
Yeah, okay, so 1, 2 and 5. Right, question 1, will I do them all out? Will I do everyone? Every single one? Good idea, I think. Right, number 1 is y is equal to the inverse sine of 6x So, as I say, doesn't matter what it is, put it over 1. So x is whatever is above the line, which is 6x. A is whatever is below the line, which is 1. Got it? Right. Inverse sine formula is 1 all over the square root of a squared minus x squared. No, inverse sine, sorry. A squared minus x squared. Yeah, that's fine. I have it right. Okay, so fill in. It's 1 all over the square root of a is 1. So it's 1 squared minus, instead of x, I'm putting in a 6x to b squared. And then you differentiate the angle. So then you differentiate 6x, and what you get? 6. Okay, so that would be 6 on top. 1 by 6 is 6. Underneath the line, it's 1 minus 36x squared. That's my answer. Is that alright? Did you get that? Okay, next one is the inverse tan of 3x, so differentiate that. So the formula for inverse tan is a all over a squared plus x squared. So you stick that over 1. So that means x is equal to, everywhere I see an x, I'm putting in a 3x. Everywhere I see an a, I'm putting in a 1. Okay? So that would be a is 1 all over 1 to be squared plus 3x all to be squared. And then now you differentiate the angle. So you differentiate 3x and you get what? 3. I'll do it so. 1 by 3 is 3. Underneath the line I've 1 plus squared is squared 3, you get 9, square x, you get x squared. There's your answer. Is that right? Yes. Say that again? Okay, Brent. Is that okay? Next one, the inverse sine of 2x plus 1. So again, put it over 1. X is equal to whatever is above the line, and a is equal to 1. So the inverse sine formula is 1 all over the square root of a squared minus x squared, which is 1 all over the square root of 1 to be squared minus 2x plus 1 to be squared, and then you differentiate the angle. So you multiply it by, differentiate 2x plus 1, you get 2. Is that right? Okay. Do you need to multiply it out underneath the line? I don't think so. Did you multiply it out? Yeah. So it's 1 all over the, I'll just multiply it out because you want the answer, but I don't think you need to. Sorry, I'm going to multiply 1 by 2 is 2. So it's 1 minus square the first, put it in brackets because of this minus. So square the first is 4x squared, twice the first by the second is 4x, square the last, you get plus 1. Okay, I put it in a bracket because of the minus, it's going to change all the signs. So that's 2 all over the square root of minus 4x squared minus 4x. The 1's cancel, 1 minus 1 is 0. Is that right? That's your answer. Are we good with that? Okay, I'll take that as a yes. Okay, next one. Right, the inverse tan of x squared. So inverse tan formula is a all over a squared plus x squared. So stick it over 1. So everywhere I see an x, I'm putting in an x squared. Everywhere I see an a, I'm putting in a 1. Which I will always be doing, by the way. Always put in a 1 for the a. It's the easiest way to do it. Right, so 1 all over 1 squared plus x squared, all to be squared. And now you differentiate the angle. So differentiate x squared and you get 2x, don't you? So that would be above the line 2x, below the line I have 1 squared is 1. X squared to be squared is x to the power of 4. And that's your answer. We good? Right, okay, that's all of number 1. Number 2. Did you say number 2? You didn't. You said number 2? So y is equal to the inverse sine of 3x minus 1, and they give me the answer. Okay, so they give me the answer, so I'm going to get the answer. So put that over 1. Everywhere I see an x, I'm putting in a 3x minus 1. Everywhere I see an a, I'm putting in a 1. Right, and when I differentiate inverse sine, I get 1 all over the square root of a squared minus x squared. So filling that in, that's 1 all over the square root of 1 to be squared minus 3x minus 1 to be squared, and then you differentiate the angles. So differentiate 3x minus 1 and what you get? 3. Okay, so then I just need to multiply it out and make it into the form they want. So 1 squared is 1 minus, I'm going to put this into a bracket. Square the first, 9x squared, twice the first by the second is minus 6x squared, the last is plus 1. Right, so that's 3 all over the square root of, so when you multiply in by the minus, it would be 1 minus 1 is 0, so I have minus 9x squared and I have plus 6x, and that's what they said the answer was going to be. They've just written it in a different order. Is that alright? Okay, are we good? And 5? 5? Right, okay. So 5, they told you to use the product rule. Right, so I hope you haven't forgotten the product rule. Sorry. So 5 part 1, y equals inverse sine, x times the inverse sine of x. So it's x multiplied by the inverse sine of x. So you let u is equal to the first term, v is equal to the second term in the product. Differentiate u and call it du dx. When you differentiate u, you get the number in front of x, which is 1. Right? Differentiate dv dx. And this is straight from the formula book because there's no angle here. So differentiate inverse sine of x over a, so that's 1. So it's, inverse sine 1 all over the square root of 1 to be squared. Take away x to be squared. Is that alright? And then u times dv dx plus u times, v times du dx is the product formula. So it's u is x multiplied by dv dx, which is 1 all over the square root of 1 minus x to be squared, plus v is inverse sine of x multiplied by du dx multiplied by 1. That'll do me. Don't bother multiplying it out. You're not going to simplify that by multiplying it out, so that'll do. Is that alright? Are we good? And the second part of number 5, right, is part 2 is y is equal to 2x the inverse tan of x. And again, I'm using the product rule. Right, in the exam, they won't tell you to use the product rule like they did here in the question. You need to recognize that that's a product. Okay, so u is equal to 2x. V is equal to the inverse tan of x. Right, du dx is equal to 2. And dv dx is equal to a is 1, x is x. So inverse tan of 1 all over 1 squared plus x squared. Okay, so I'm filling in a is 1 and x is x. Is that alright? Okay, So I just filled that into the formula. So then it's u times, I'm not writing out the product rule again, so it's u times dv dx, which is 1 all over 1 plus x squared, plus v times is the inverse tan of x times du dx, which is multiplied by 2. And again, leave it like that. Multiplying it out is not going to simplify it. Okay, is that right? Are we good? Right. Are we okay with inverse trigonometric functions? Can I move on? Yeah? We're okay? Right, okay. So I'm moving on to differentiating exponential functions. You haven't this done, have you? No. Right, for your notes. So differentiation of exponential functions. That says exponential. I know it looks nothing like exponential, but that's what it's supposed to say. So if the rule, and it's in the log tables, right? So when y equals e to the power of x, dy dx is the exact same thing, right? And there's a second rule, right? Okay, so there's a second rule, it's written in the log tables. So the rule is, right, if there's a constant in front of the x, so if it was e to the power of ax, right, dy dx equals a times e to the power of ax. And when we do examples, you'll see what I mean. Okay, so they're the two rules that we'll be talking about that are in your log tables. Okay? So, example 1. Y equals e to the power of 4x. Can I move it up? Right, so if y equals e to the power of 4x, right, when you differentiate, girls, you get the exact same thing. So if you start with e to the power of 4x, e to the power of 4x is in your answer. Right? So you get the exact same thing. But then you must differentiate the power. So you must differentiate 4x. See the way 4x is the power? So differentiate 4x and you get 4. So your overall answer is just putting the 4 at the front. Do you have to put the 4 at the front? No. Right, okay, but you might see it written like this. E to the power of 4x. That's my answer. Okay? So when you're differentiating e to the power of something, you get e to the power of the exact same thing, and then you differentiate the power. Okay? Example 2. So if I have y is equal to e to the power of 2x plus 4. Differentiate, and you get e to the power of the exact same thing. So you get e to the power of 2x plus 4. But then you must differentiate the power. So when you differentiate 2x plus 4, what will I get? 2. And we normally write the 2 with the front. So it's 2 multiplied by e to the power of 2x plus 4. And that's my answer. Is that all right? Okay, example 3. Can I move it up? Y equals e to the power of x squared. Right, e to the power of x squared. So differentiate dy dx, and you get e to the power of the exact same thing, so e to the power of x squared. Now you differentiate the power. Differentiate x squared, and what do you get? 2x. So it's multiplied by 2x, and we can write the 2x at the front. So it's 2x e to the power of x squared. That's your overall answer. Is that right? Are we good? Right, okay, example 4. So y equals e to the power of 2x sine x. How will I differentiate that, please? What will I use? Product rule, very good, okay. So it's e to the power of 2x multiplied by sine x. So it's a product, it's one term multiplied by another term. So you have to use the product rule. So u is equal to e to the power of 2x, and v is equal to sine x. Differentiate u, call it du dx. Sorry, that's du dx. So differentiating that, you'll get e to the power of 2x, e to the power of the exact same thing. Now differentiate the power, multiply by what? 2. And over here, dv dx, in my log tables, differentiate sine, and you get cos, so it's cos of x, and then you differentiate the angle, so that'll be just multiplied by 1, so I won't bother putting that in. Is that alright? Okay, then fill out your product rule. Sorry, where did that go now? Just give me a sec. This is it. So I'm not going to write out the product rule, but it's u times, which is e to the power of 2x, multiplied by dv dx, which is cos x, plus v times, which is sine x, multiplied by du dx, which is 2e to the power of 2x. I just wrote the 2 in front. Is that alright? Okay, and there's nothing to be gained from multiplying that out, so that's your answer. Is that alright? Is it okay? Can I move it up? Have I cut people off? Probably. Right, okay, I think that's the end of my examples. And do you want a 5-minute break there before I lay into other stuff in a few minutes? Right, so I'll stop this.